Newton's first law of motion.
By observing the motion of objects on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts upon them. He observed that when a marble rolls down an inclined plane, its velocity increases. The marble falls under the unbalanced force of gravity as it rolls down, and it attains a definite velocity by the time it reaches the bottom. The velocity decreases when it climbs up, shown a marble resting on an ideal frictionless plane inclined on both sides. Galileo argued that when the marble is released from left, it would roll down the slope and go up on the opposite side to the same height from which it was released. If the inclination of the plane on both the sides is equal, then the marble will climb up the same distance as it covered while rolling down. If the angle of inclination of the right side plane was gradually decreased, then the marble would travel a farther distance till it reaches the original height. If the right side plane was ultimately made horizontal, that is, slope is reduced to 0, the marble would continue to travel forever, trying to reach the same height that it was released from. No net force is needed to sustain the uniform motion of the marble. Newton's first law of motion. A body at rest will remain at rest, and a body in motion will continue to be in motion in a straight line with a uniform speed, unless it is compelled by an external force to change its state of rest or of uniform motion. According to Newton, a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. Object is in the state of rest, it will remain in the state of rest, and if it is moving in same direction, it will continue to move with the same velocity in the same direction unless an external force is applied on it. This property of body is called inertia. There are three different types of inertia. They are inertia of rest, inertia of direction, and inertia of motion. The passengers standing in a bus fall backwards when the bus suddenly starts. Why? Because the feet of the passengers start moving along with the bus as it is in contact with the floor of the bus, whereas the upper part of the body, due to inertia of rest, tries to remain stationary. Thus, the lower portion of the body moves forward and the upper portion remains at rest due to inertia of rest. Inertia of direction is the tendency of a body to maintain its direction of motion. See, a stone tied. Due to inertia of direction, the stone tries to maintain its direction every moment. This can be confirmed when the stone flies tangentially when the string breaks as shown below. When a running bus stops suddenly, the passenger tends to lean forward. The reason is that in a running bus, the whole body of the passenger is in the state of motion. As the bus stops suddenly, the lower part of his body, being in contact with the car, comes to rest, but his upper part remains in the state of motion due to the inertia of motion. Thus, he leans forward.